Hello everyone, welcome back to the Coding Explorer. This is Pradyumna and let us continue our exploration on the world of software. So this is my new series in which we are going to understand the world of computer vision, and in that we are going to go through Python computer vision. But what is computer vision? It is actually a field of artificial intelligence that helps computers to understand the visual world. Basically, they can analyze photos, videos, and then find relationship between them. It is used in various fields such as security cameras, self-driving cars, healthcare, automation, etc. Now let us understand about security cameras, because we are going to create a smart security camera today and it's going to be very good. So basically they use computer vision for face detection and also object tracking. So in this first part we are going to implement face detection, and in my next video we are going to implement object tracking. It is also used by the defense sector to keep track of criminals. So basically what they do is they have object tracking and also face detection, and they use face recognition to see who is in the videos and also keep track of where they are going. So let us see what we are going to actually create today. So it will basically be a Python program like this. So it will be taking the images from your webcam, and then it will find faces, and whichever faces it is found, it will put a bounding box around it, and also it will have the timestamp, and it's gonna save that video. And also if it finds any faces, then after every 5 seconds it will make sure that the face is saved so that you can keep track of who had been seen. So let us begin. I have already created a project and then I have written the code so that I can easily explain it quickly. So we basically need the computer vision library. For that you need to install it. So you have to take this code. So you say python install opencv python. So you take this code and basically go to your terminal over here, and then yes, you just need to enter it and click enter. It will install this library. Since I've already installed it, I need not do it. After that we are gonna implement it. So basically you also need this XML file which I've uploaded in Github, so you can get it from there, because we need this to detect the faces in the images. So let us begin. So we import the computer vision library. Now since you're using the webcam, you need to say you need to call the webcam to give you the videos. So you say webcam is equal to cv2.videoCapture0, and then you need to get the width and height of the image that will be captured by the webcam. So you take the width. So you say webcam.get3, webcam.get4 to get the width and height. Now since you need a video stream that you're gonna save the video to, so you're gonna say video stream is equal to cv2.write video writer. So I'll call it as face detected.avi. So basically it will be a video that will be stored like this, and then you say cv2.video fork for mjpg. It basically means that you're gonna store motion jpeg video, and then you're giving the frames per second of the video, and also you will give the width and height of the video that you're gonna make. Next, now we'll understand what is Haar Cascade. So it's a machine learning algorithm which helps us to detect a particular object in an image or a video. It can detect an object irrespective of its scale in the image and wherever it is located. So it can detect various objects. Now we are implementing for face. You can do it for eyes and various things such as even nameplate or anything like that. So it's basically how it's made. It's given a large data set of images where it is given that this is the object it is detecting. So for example, if you're training for face, you give a large data set of many faces and you say that this is a face, and then you give a large data set of negative images, which basically means the images that are not faces, and tell it's not a face. So it trains on it, and then it starts to detect with the faces in the image. So what Haar Cascade basically does, it gives us the bounding box that where the object is detected, for example the face. This is how it will be seen. So let us begin now again. Yes, let us continue. So you have this face cascade, so you have to call this XML file. You need to take it and then you say cv2.cascade classifier. You need to give the file. So here it's face, so I have this ready, and you have to take this XML file. You can, if you are detecting something else, like as I mentioned eyes or nameplate, you need to get that file from Google. You can get it. Now let us do for faces. So now you're gonna check if the webcam is available. So you say if webcam is opened and it's false, so it means that the webcam cannot be read, or you don't have a webcam or something like that. So you have to say unable to read the camera feed, and then we'll continue. So since it's a video, basically a video is nothing but a series of images taken close together. So what we're gonna do is we're gonna create a while loop in which we're gonna be taking images from the webcam. So let us we'll start this loop, and then we have to get the image from the camera. So you say webcam.read. It basically gives us two parameters. So this ret tells us if the image is captured or not. If it's not captured, then ret will become false, so you don't have any frame. Now this frame is basically the image that is being read from the camera, and if ret is true, that you are able to read it, then we are gonna perform the operations, or else the frame won't have anything and it will cause a problem. It will give errors. And then we're gonna grayscale the image, because if you have the RGB format, it will be harder. So if you have a grayscaled image, it will be easy. So you say cv2.cvt color, so you're changing the color, and you want to change the color of the frame. So you say frame, and you say cvt2 dot color bgr to gray. Actually in cv2, what it does is it doesn't represent images in RGB format. Instead it represents it as bgr. So that's why we say bgr to gray. So you convert it to grayscale. Now you have the grayscale image in gray image. Now you need to get the faces. So you say face cascade, as we had created over here. We say face cascade dot detect multiscale. So you are telling detect multiple objects from this grayscale image, and after that you get the bounding boxes of the detected faces, and then store it in this faces variable. And then you, since it can be multiple faces that are there in the image, you need to make sure that you can go through all of them, and also you need to form the bounding box. So you say for x, y, z and h in faces. So it will look something like a list of x, y, w and h. Basically it is the xy coordinate and then the width and height of the image or the face that is detected. So you'll have something like the xy coordinates, and then you'll have the width and height. So you're gonna iterate through it, and when you iterate through it, you can directly say x comma y comma y comma h w comma h, so that you did not again create a variable and then do to it. So you need to draw the rectangle. So what we're gonna do is we say cvt dot rectangle on the frame that is there, and then you have to give the position. So it's gonna be x comma y, and also you need to give the last position. Basically this will be the top left point of the image, and this will be the bottom right point of the image. So since they have given since Haar Cascade gives us width and height, what you need to do is you need to add the width and height to the x and y coordinates of the left top coordinate, and you get the right bottom coordinate. And then you need to give the color to it. I have given 0,255,0, and then you need to give the thickness of the rectangle that is formed. After that you'll get the frame. The frame will be changed, and then You also need to create the video, basically the video stream that we had, which is gonna have stored all the images in form of a video. You'll say video stream dot write, which frame you're writing, the current frame, so dot write frame. And then you can also display it currently. If you're running the program, you can see what is detected on the frame. And then if you want to stop the program, that is, you want to quit and you want to everything close, you have to say if cv2 dot wait key of 25 is odd of q, then break, so it breaks this loop. Or else if you even try to close the window, it will again come back. So that's why we need to say we have to check if q button is pressed, and then if it's pressed, you need to break this loop. And after this loop is broken, what you have to do is webcam.release. So basically you say that the webcam that is reading from, I'll just stop reading it, so you can stop the webcam. And then you were also streaming to the video, so you can stop that. And all the windows that were being displayed, basically now it's one, so that will get closed. So this is the basic part. Now we'll just run it and then see the part where we have to store the images, the faces that is there, if it's detected, and also the timestamp. So let us see this. So this is how it will look. You will have the faces being detected and being displayed over here. You can see that even if I move, it is able to detect me. Now let us see how to display the timestamp and all that. So let us implement the whole thing. So now we need this time library. We need to import it because we need to create a timestamp. So import this, and till here everything remains the same. And then since you are displaying the text, you need to create the font, whichever font. So I've just given cv2 dot font Hershey simplex. And then we need this last time variable, because as I told you, after every 5 seconds, if the photo of the face is seen, we're gonna store it. So we have to keep track of the last thing we store, last time we stored, and then we're gonna check it, and then if it's greater than 5 seconds, we're gonna save it. So here again the same thing is there. Now when we implement the timestamp, so basically we first need to get the time. So we say current time is equal to, so first we get the time. So basically it's it gives it in terms of seconds, and it will have even decimal representation. Now we need to convert it to local time. As you can see, local time, it converts it to the year, month and day, all those, that type of format. But then you need to convert it to a type of a text. As you saw, it was like given the day and then you have the date in everything. So you need to say ASC time. So basically it converts it something like this using what I was given by time.local time. And then you have the string as the current time. Now you need to add it to the image that we had captured. So you say cv2.put text. Where do we need to put? We need to put it in the image, that is the frame. And then what do we need to put? We need to put the current time. We need to give the position on where it is there. We need to give what font it should be. And then we also, if you see here, you need to give image, text, you need to give where it is there, you need to give font, you need to give the scale, and then you need to give the color. As I told you, cv2, it is bgr format. So if you need to make it red text, it needs to be 0,0,255. and then you can see you need the thickness, so I give 2. And then I just gave the line type, so I give it as line AA. And then this gives the timestamp on the image. Now as I told you, if you see the face even after 5 seconds, you need to store it. So basically what you do is, if time.time, you need to get the current time, then the last time is stored, you get minus last time if it's greater than 5. That is, if it has been 5 seconds after like the last time you stored it, then you need to do it. And you also need to make sure that you have faces. If you don't have faces, then it doesn't make sense to store it. So if there are faces, that is basically you check if the number of faces is greater than 0, because if it's the number of faces is it's not there, it will become 0. So you have to make it greater than 0, and then you need to make last time to this time, because we're going to store it now. And we say cv2.imWrite, so basically it writes this to an image, and then you need to give the image file. So since we're gonna save it so many times, it is better to also give the time that we're storing it. So you say string of last time. It will actually not be in the format of the one that was there, it will just be in terms of seconds, which we actually cannot differentiate, but it'll make sure that you don't have files that are the same thing and it has problems. So you say string of last time plus, you can just say face.jpg, and what do you need to store? You need to store the frame. But then if you want to store only the face, then you can also do that. You say you need to do this. You need to say face image is equal to frame of. So but here what you need to do is, again you need to loop through all of this, and then you need to get the bounding box, and then from the bounding box you need to get the image. So instead of that, we directly store the image, because if we have multiple faces, it'll create a problem. That is why we have just stored the whole image. But you can also do this if you want to just get the one face from it, and then after that you can just store it. And after this, the same thing. So this is how it will work. You can also check it. So let us run and check. So here you can see that we have the timestamp, we have the face being detected and the bounding box, and also after every 5 seconds you can see that the images is being stored, and this is working. And again, if we see after every 5 seconds, if the image face is seen, it's being stored. So this is how it will work. So that's what we created today, and in my next class we'll complete this project by implementing object tracking. And before you leave, let me tell you that what we did today is put up in GitHub, and I've provided the link in the description. So you can come here and you can click on the class 1, and here you can get the Haar Cascade file which you will need. And also if you have any doubt with the code, you can just check out over here. You'll get everything over here. And if you have any doubt, you can put it in the comment section. I'll respond as fast as possible, and I hope that you were able to understand everything. Let me tell you a fun fact. Security cameras were actually created by a German engineer to watch a rocket launch, and not actually for surveillance. But later, seeing its use cases, it was used for surveillance. So thank you everyone. Please learn, like, subscribe and share. And if you have any doubts, put it in the comment section. I'll respond as fast as possible. And click on the bell button to get the latest notification. Thank you everyone.